Welcome to Module 3.14, where we'll explore the fundamentals of statistical analysis and quantitative research. Statistics provide the tools to organize, summarize, and draw inferences from numerical data. In this module, we'll examine descriptive statistics for summarizing data, basic concepts in inferential statistics, and common statistical tests used in healthcare research. Understanding these elements will help you both conduct appropriate analyses and critically interpret statistical findings in research literature. Descriptive statistics organize and summarize data to make it meaningful and interpretable. Measures of central tendency identify the typical value in a data set. The mean represents the average, the median, the middle value, and the mode the most frequent value. Measures of dispersion characterize variability. Range shows the spread. Variance quantifies deviation from the mean, and standard deviation expresses this deviation in the original units of measurement. Frequency distributions display how often values occur, while percentiles and quartiles divide data into meaningful segments. Data visualization through histograms, box plots, and scatter plots transforms numbers into comprehensible patterns. Together, these techniques convert raw data into meaningful information, revealing patterns, outliers, and distributions essential for understanding healthcare phenomena before applying more complex analyses. Inferential statistics allow researchers to draw conclusions about populations based on sample data. Population parameters are the true values we seek to estimate using sample statistics calculated from our data. Hypothesis testing provides a structured approach to determine whether observed effects likely represent real phenomena or merely sampling variation. P-values indicate the probability of observing results at least as extreme as those found if the null hypothesis were true. Significance levels, typically set at 0.05, establish thresholds for rejecting the null hypothesis. Confidence intervals indicate the range within which the true parameter likely falls, providing information about both effect size and precision. Researchers must balance typal errors, falsely rejecting a true null hypothesis, against type 2 errors, failing to reject a false null hypothesis. These concepts form the foundation of statistical inference in healthcare research. Researchers employ various statistical tests depending on research questions and data characteristics. T-tests compare means between two groups, independent TT tests for separate groups, and paired t-tests for before-after or matched designs. Analysis of variance, ANOVA, extends mean comparisons to 3 or more groups with factorial designs, examining multiple independent variables simultaneously. Chi-squared tests analyze relationships between categorical variables commonly used in prevalent studies. Correlation quantifies relationships between continuous variables, with Pearson's R measuring linear associations. Regression analysis predicts outcomes based on one or more predictor variables. Linear regression for continuous outcomes. Logistic regression for binary outcomes. Selecting the appropriate test requires considering the research question, variable types, and assumptions underlying each test. Understanding these common analyses enables researchers to extract meaningful insights from healthcare data.